right, so page 18 in your notes, page 18. Every day, people watch 1 billion hours of YouTube videos. That breaks down to every single person on Earth watching YouTube videos for about 8.4 minutes per day. For US teens, in any given day, the amount of time spent watching YouTube videos is approximately normal, with a mean of 18.5 minutes and a standard deviation of 5.3 minutes. Find the probability that a randomly chosen US teen watches YouTube for more than 25 minutes in a given day. I'm going to give you guys about 2 minutes if you need the full 2 minutes to do this first question. This is a straightforward, normal distribution problem. So draw your curve, label everything, write your probability notation, calculate the probability. Mean and standard deviation. All right, so your picture should look like this. Mean is 18.5, standard deviation is 5.3. We want to know the probability that a randomly chosen US teen, so you could think of it as a sample size of 1. 25 is our boundary. Probability notation, we want to know the probability that X, just one person, is greater than 25. So lower boundary, normal CDF, lower boundary of 25, upper bound of something stupid big. Mean of 18.5, standard deviation of 5.3. What did you get for the probability? Yep, it's about 0.11, approximately. So putting this back in context, what this is saying is that out of the entire population of US teens, the probability that you randomly select one US teen and they watch YouTube for more than 25 minutes in a given day is about 11%. All right, let's look down at the second part now. Suppose we choose a simple random sample of 10 US teens. Let X bar equal the mean amount of time spent watching YouTube videos for the sample. How would I find the mean for the sampling distribution for X bar? Yep, it's going to be exactly the same as the population mean. The mean of X bar is the mean of the population, which means it is what for this? 18.5. Before I can calculate the standard deviation, what do I have to do? See if it passes the 10% condition. So how do I check the 10% condition here?
Is it 10 is greater than or equal to?
Less than or equal to?
Less than or equal to 0.10 of all. Wait, what is it?
All US teens, yes. 10, our sample size, is less than or equal to 10% of all US teens. Is that a reasonable assumption for us to make?
Yes.
Yes. Okay, so then we find our standard deviation. How do you calculate the standard deviation for a sample? says up in the quick notes box.
Sigma over square root of n.
Sigma over square root of n, where sigma is the population standard deviation divided by the square root of the sample size. What was the population standard deviation? 5.3. So we're going to do 5.3 divided by square root of 10. And that comes out to be what? Yep, 1.676. Question before we go and do number 3. What would the shape of the sampling distribution be? Approximately normal. How do we know? Because it's the same as the population. Right here it said that the population was approximately normal, so the sampling distribution will also be approximately normal. I want you guys to do number 3, similar to number 1, but now we're doing it for the sampling distribution, not for the population. Take about 1.5 minutes to do number 3. Probabilities can never be bigger than 100%, so they're never going to be bigger than 1. So if you see something on there that's bigger than 1, then it's been written in scientific notation.
Did I say that?
Guys, what does the E on the calculator mean? Scientific notation. It means you're going to move your decimal.
E minus 5 means that there's 4 zeros?
Yes, there's 4 zeros after the decimal before you get to your numbers. All right, so your normal distribution should look like this, which looks a lot like number 1, except it has a different standard deviation. That's the only change in our picture. In my probability notation, notice I now have an X bar instead of just an X. What's the difference in meaning, X versus X bar? Yes, this is a sample mean. This is, I took a group of people and I averaged this time. And then you're going to do normal CDF, lower bound of 25, upper bound of something stupid big, mean of 18.5, and standard deviation of 1.676. And we got that weird scientific notation. How many leading zeros should we have after the decimal?
4.
4 zeros, and then we start with our number. So we move the decimal place 5 places, which gives us 4 leading zeros. Compare this probability to the one that we found up in number 1. Remember, in number 1, we said that was the probability of selecting one teenager out of the whole population, and the probability that that one teenager watches YouTube for more than 25 minutes on that day. What is this the probability of? Yeah, getting a sample of 10, averaging all of their watch times, and getting an average of more than 25. There's a much lower probability that if I take a group and I average that time, that it's going to be farther away from the mean. All right. I want you guys now to have pages 20 and 21 open up side by side. You need to be able to see both of them. And we are going to do something similar to what we did yesterday. Yesterday we were talking about how tall do you need to be in the NBA. Yesterday, what position were we looking at? Power forwards. Today, we're going to look at shooting guards. If you look at page 20, it shows you that there's how many shooting guards, at least when I got this data? 123. Look down at the bottom of page 20. There's a dot plot and summary statistics. How would you describe the shape for the population? Yes, skewed to the left. Skewed to the left, or left skewed. Again, this is for our population distribution. When you look at the summary statistics, it tells you the mean. What is the mean? 76.333. So that is mu. What is the standard deviation? 1.673. So this is sigma. All right. You guys are going to do a total of 6 random samples for me. The first 3, I want you to have n equals 2. What does that mean? Yep, you're going to pick out 2 players. How are you going to find those 2 players? Yep, math, probability, option 8, random, no repeat. You're going to go from 1 to 123. Little n is 2. You're going to use those 2 numbers to go and find the players on the table. You're going to look at those 2 players' heights, and you will average those 2 players' heights. You're going to write those answers down on these lines here. You're going to do a sample of 2 and find the average, a sample of 2 and find the average, a sample of 2 and find the average. Once you have those 3 averages, you're going to come up here and put a dot up on the dot plot. Right here, you're going to put it on this dot plot here. After you put those 3 dots up, you're going to go back to your seat and you're going to do the same thing again, but this time with how many people in your sample? 10. All right. So you're going to calculate 3 averages, samples of size 2, come and put your dots on the board, and then you're going to do 3 samples of size 10. Please make sure that you're not averaging the numbers that the calculator gives you. You are taking the numbers that the calculator gives you and using those to go find the players and averaging those heights. All right, so with our last 2 minutes, I want you to look at the first graph. This would be the sampling distribution of X bar, where n equals 2. We had samples of size 2. Every single one of these dots is a different X bar. What do I mean by that? Yes, this is a different average of size 2. Different average of size 2. How would you describe the overall shape of the top one? Yes, except for this little bit over here. Yeah, I would call it a slight left skew. It does have that approximately normal look to it. It is not as skewed left as the population distribution, but this is still skewed left. How do you find the mean for a sampling distribution? It's the same as the population mean. What was the population mean here? 76.333. How do we find the standard deviation for a sampling distribution? We check our 10% condition first. And then we do sigma over the square root of n. Is our sample size less than 10% of the population here? Samples are size 2. And our population had 123, right? All right. What was the sigma for the population? 1.673 over the square root of 2. What is 1.673 divided by the square root of 2? Yes. We're going to call it 0.118, or 1.18, sorry, 1.18. We're going to talk about that bottom dot plot tomorrow, but just visually, is this one still skewed left?
No, I think there's a problem.
This one is more approximately normal than the other one. The other one was getting closer to being approximately normal. This one is much more approximately normal. What else do you notice about the bottom dot plot compared to the top one? Less variability. So what do you think happens to my standard deviation then? It decreases. We will calculate that tomorrow. We will finish this off tomorrow. Have a great rest of your day, guys. I will see you tomorrow.